Here we're asked to solve for x, find the roots, find the zeros, find the x-intercepts. All of those things all mean the same thing, but we're actually looking for all real and complex solutions. So as we go through here, the first thing that we want to do is look for our possible rational roots here. So possible rational roots using the rational root theorem just tells us that that is positive or negative all of the factors of our constant, which is 4, over all of the factors of our leading coefficient, which in this case is just 1. So possible rational roots are just positive or negative 1, 2, and 4. So once we find those, I'm going to start plugging those numbers in using synthetic substitution. I can also call it synthetic division because we are going to factor this as well. But what I mean by that is I'm going to start with just positive 1 here and then plug in the coefficients here. So 1, negative 1, 4, and negative 4. Bring down the 1, multiply 1 times 1, add to get 0, multiply 1 times 0, add to get 4, multiply 1 times 4. And since I get this remainder, that's good. That means that we can factor out x minus 1 because I know positive 1 is a 0. So what that means is that I factor this and it becomes x minus 1, and then this gives me what's left over. So I have x squared plus 0x plus 4. So now when I'm trying to solve this, I could keep plugging in numbers here, but basically when I look at this, I want to see that I can solve this here because I know x minus 1 equals 0. I'm going to get x equals positive 1. Then on this part of the problem, I have x squared plus 4 equals 0, and I can solve this by using square roots. So I subtract by 4 from both sides, x squared equals negative 4. I take the square root of that, which is going to give me x equals plus or minus the square root of 4, and then I'm going to pull out that negative to make that I, and then simplify that to get plus or minus 2i. So now looking back at it, makes sense to have 3 answers here because I have x equals 1, then I have x equals positive 2i, x equals negative 2i, and the degree here should tell me how many total solutions I can have.